Hello everybody. In this video we're going to talk about the one important feature about the simulation environment, which is the stream analysis. Um, and just to be aware of this feature, it's and sometimes in many cases you would be interested in analyzing or getting some information about one of the streams in the flow sheet. For instance, this product stream, it is a product of the simulation, so you don't know the values, or you don't have the temperature, the pressure, the composition, and to know them you go to the product and then go to the results and then see, and in this list you can extract any information that you're interested in: the pressure, the temperature, the mole flows, the mole fractions, whatever. So you can have a good or good knowledge about this stream and all its information. And to be able to do some analysis like we did in the properties environment, you have to import this data into, or export them into the properties environment, so that you can do all these analysis, like to get the vapor fraction, to get the as a function of temperature, like to change the variables and then see how it changes. And it's not going to be an easy thing to do, is to go for take the data from here, go to the properties environment, do the analysis, and go back to here. And that's why the stream analysis is one very good tool that you can use. To do the stream analysis, you can either go to or right click on the stream and then you go to analysis, or to select the stream and go to stream analysis from here. It's the exact same list. um, in by right clicking you can find many options, like the input and results, which are the same as the inputs and results here. You can go to, you can find some other things like insert block, which is putting a block in the middle of the stream. So if you want to insert a block in the stream, so you can break it and then choose which stream. Anyways, we will come to it later. But this is one nice option actually in Aspen Plus. You can rename it, copy and or cut. You can reconnect it as we mentioned last time. You can read out the stream, hide, or choose a color style and make it, for instance, green. Then you can so its color is green. It's, I don't know if it's clear here or not. Maybe you can make it a red stream so you can easily see it. So it's helpful in case you have a stream that's important and you want to make it like very clear in the flow sheet. Anyway, so the point I want to focus on now, or the option, is the analysis. We'll find here some information that you can extract from the results automatically or quickly without going to the analysis, like the component flow, the composition, and the point. You can check them; they are very simple and straightforward. You can plot the PV curve, the VT curve, the PT envelope. For instance, let's try the PV curve. I want to try for let's say pressure of 0.01 up to zero point 0.1, and then see how it looks like. In this case, I think it's all in the, I need to go in a different range, maybe from uh, point 0 or point, oops, point 0.09 to point 0.1. Maybe we can do that. This might get a nicer curve. So this is the PV curve. We can increase the pressure a little bit, so you can have the possibility to change the values. I can make it to 1, and then see what we get. Again, I have a lot of points here and a very wide range, so the range of interest is not here. So I need to go to a point 15. It needs kind of some trials to know the exact range that's gonna show some results. So here you can see the PV curve, how it looks like, and how the volume changes with pressure. And as the pressure increases, it turns from vapor to liquid, and the vapor has very high volume, and the liquid has very small volume. So that's why we have um, uh, I'm sorry, the vapor fraction. This is high vapor fraction, very low vapor fraction. So the PV is not the volume; it's the vapor fraction. Anyway, so you can still play with these numbers and get results without the need of defining the composition of the stream or the temperature or the pressure. The point of interest to me now is these two, the stream properties and the bubble and dew point. For the stream properties, it's exactly like the what we did before, which is here in the home button. I think, yeah, it was in the analysis tab. Um, we were able to do or in the pure component or in the mixture. This was the mixture. I'm sorry. It's exactly the same layout. If you check this and this, exactly the same layout. The only difference here and there is that we don't need to define the stream composition, which is a very, very, very nice feature. I have just to delete this to make sure that the simulation will run without any issues. Um, um, and as we see here, you can do the same thing, get the values of heat capacity and the vapor fraction. You can do other physical properties like density, viscosity, whatever the variable that you're interested in. And then you define the temperature range and the pressure, and you run the analysis. And by this, you can get the results. And as you see, the exact same results that we got last time. The As the temperature increases, the CP increases until it turns into vapor, and then the CP drastically decreases. And this is the same thing that takes place here, that it increases suddenly because of the vaporization. And there is, as you see here, there is boiling range because it's a mixture, it's not a pure component, so it's great. The point I want to focus on now is that we didn't need to define the composition of the stream. It takes the inputs from the stream and does the analysis based on this. The second thing, which is a very nice thing actually, and I personally use it a lot, because in many cases you might be interested in separating this mixture either by distillation or by flashing. And in this case, you need to know what is the boiling range. Of course, we saw the boiling range here. Yeah, one more thing, in the analysis, you still can find your results of analysis even if you close this tab, because in the analysis folder here, you can find the results, and in the results you can see all the numbers. You can change the units from Fahrenheit to Celsius, for instance, and here you can see that the vapor fraction starts from 85 to 95, so you know this is the boiling range. This is one way to finding the boiling range. The other way is to go back to the stream analysis and do the bubble and dew point. There is just one option, especially for the bubble and dew point. You can choose either to do one of them or both, and you choose the pressure range. I know that this stream, from the results of the product, that its pressure is 1 atmosphere or 1 bar. So I can simply um, go to stream analysis, bubble and dew point. It gives you a wide range actually, which is the default, from 1 atmosphere to 1 atmosphere to 10 atmospheres. I personally like to do it for a narrow range. If you're interested in the wide range, it's gonna be nice. But if I am interested in, let's see the results first, and then see what we get. So it gives you the results as a table, and then gives you the results as a plot. It does both, and for some reason it just plots in Fahrenheit, so you have to change it manually, and then it will replot it in Celsius if you're interested. But the problem that faces me here is that I'm not interested in all this range. It's good to see that the data, but I'm interested in just 1 atmosphere, which is these first 2 points. And here it asks you to put more than 1 point. So I usually, what I do is to go from 1 to 1.01, and ask it to just plot 2 points, and that's all. So it's gonna give me the numbers of two pressures only, which is almost the same pressure. It's 1 and 1.01, and you'd see the difference is 1 point or 186 Fahrenheit and 186 point some small decimal place difference. So you can find the boiling range again. You can um, put it in where the results. I don't know where did it. Oh, here are the results. You can put the results in Celsius, and do the plot in Celsius. You can have a feeling of the numbers. So it's from 85.5 to 91. This is very close to the results that we got from the PV curve, but this gives you the exact numbers. In the other case, it gives you the numbers of the vapor fraction. So it says from 85 to 90, but here it's actually the exact numbers from 91 to 85. One thing to keep in mind or to notice if you want to export the numbers or look for the numbers in the table, it doesn't do both in the same line. So it doesn't tell you in this pressure the bubble point is this and the dew point is this. It tabulates them in the same column. So this is the temperature and this is the pressure. This is the dew and bubble. And how do I know if it's the dew or bubble? It is the vapor fraction is 1, then this is the dew points, and these are the bubble points, and you see that the pressures are repeated. I don't know why it's plotted this way or the data is tabulated this way, because for me it's not the best way to tabulate the data, but this is the way it's tabulated. So in case you want to get the numbers out of the table, you need to just keep an eye on this vapor fraction, because it tells you which is which. Um, so this is all for this video, and I'll see you in the next video, inshallah. Goodbye.